Welcome back to The Explainer. Today, we're looking at a truly paradigm-shifting paper. It's called Toward Enactive Artificial Intelligence by researchers Banav Shevafia and Richard S. Sutton. And the premise here is absolutely fascinating. It argues that our current approach to building AI, the way we've literally been doing it for decades, might be entirely backwards. So we're going to break down exactly why these researchers believe we need a radical new foundation for machine intelligence.
Okay, let's dive into this. For the longest time, the classical model of artificial intelligence has essentially treated AI as, well, a brain in a jar. It's a completely passive entity. We kind of just assume that intelligence is all about feeding sensory input into a detached, stationary computer, having it crunch the numbers, and then spitting out a command. But what if real intelligence doesn't work like that at all?
So here's where we see the big contrast. You've got that classical brain-in-a-vat philosophy where the machine just sits there, passively waiting for data to build an internal map of the world before deciding what to do. But then you have the rebel active explorer view, the enactive view. The enactive approach argues that true perception actually requires active engagement. You can't just sit there and observe the world to understand it, you have to physically participate in it. Section 1. What is enactive AI? A new paradigm.
This definition is the absolute core of our explainer today. Enactive cognition means that perception, cognition, and action are mutually constitutive. Now, that's really just a fancy way of saying they create each other. Perception doesn't happen before action, they happen at the exact same time. Think about it. To perceive the texture of a surface, your hand has to physically move across it. Your action of moving is what creates the perception of texture. So, to perceive is to skillfully navigate the world, not just sit back and watch it go by.
Section 2. The core pillars of enactive AI. We're going to tackle each of these four foundational pillars: experience, action perception and separability, autonomy, and embodiment. As we go through these, keep asking yourself how our current AI models measure up, because understanding these four elements is the absolute key to understanding how true intelligence is built. Let's start with the first one: experience. Now, what's really interesting about this slide is this incredible quote from robotics pioneer Rodney Brooks. He said, "The world is its own best model." The enactive view argues that the real world is infinitely complex, it's constantly changing, and it's full of open-ended variability. It's way too complex for any AI to hold a perfect internal map of it in its memory. So instead of trying to memorize the whole world, the agent has to continually interact with it. The best place to store information about the world isn't on a hard drive, it's out there in the world itself. You just have to know how to look.
That brings us to Pillar 2, Action Perception Inseparability. The philosopher Merleau-Ponty called this the intentional arc. It's like a real-time, tightening feedback loop of understanding. Think about when you hear a faint noise in the distance. You don't just stand perfectly still and process the audio data, right? You tilt your head, you act, which changes your sensory input, which refines your understanding, which then makes you tilt your head slightly differently. Action and perception are forever locked in this continuous loop.
Moving right along to Pillar 3, we have autonomy. And the key word here is normativity. In classical AI, success is pretty much defined by humans. We hand the AI a dataset and explicitly tell it what's right and what's wrong. But a truly autonomous, intelligent agent needs its own internal goals to filter what matters. In nature, this is self-preservation, right? If an organism makes a mistake, it gets hurt or goes hungry. Its success is grounded in its own continued viability, which naturally shapes exactly how it perceives the environment around it.
Finally, Pillar 4 is embodiment. In enactive cognition, there's this concept called affordances. Basically, this means the world looks totally different depending on your physical body. To a human, a chair affords sitting. To a fly, it affords landing. To an AI without a body, well, a staircase means absolutely nothing, because a mind without legs has zero use for stairs. You just can't decouple intelligence from the physical form it takes.
Section 3. Why mainstream AI fails and the missing pieces.
Consider this scenario for a second. Imagine a state-of-the-art video generation model. It's watched millions of hours of driving footage. It can perfectly predict that a green traffic light turns yellow and then turns red. But does it actually understand the traffic light? What happens if the light suddenly breaks or gets stuck on red? And this brilliantly illustrates the difference. Mainstream generative models just passively track regularities. They're basically just massive statistical prediction engines that anticipate typical patterns. When that traffic light breaks, the generative model has literally nothing to fall back on, because that broken pattern isn't in its training data. And an active system, however, is an active explorer. When the pattern breaks, it doesn't just freeze, it intervenes, it corrects, and it actively explores the environment to figure out what to do next.
Section 4. The reinforcement learning connection, or structural resonance. So, evaluating reinforcement learning, or RL, reveals it actually aligns incredibly well with enactive AI in a few key areas. It's kind of like a stepping stone. It generates its own experience through trial and error, and it evaluates its actions based on the rewards it gets. That's huge. But notice where it falls short. It's definitely not perfect. It usually lacks true bodily embodiment, mostly just running in disembodied simulations. And even more importantly, humans still dictate the reward function, meaning it lacks that true self-maintaining autonomy we talked about earlier.
Section 5. The Future of AI and Enactive Practice.
I want to leave you with this final provocative thought from the source material. If true intelligence actually requires a body, what counts as a body for an AI? Does it have to be a physical robot made of metal and plastic navigating a real room? Or could an AI's body be a software architecture, equipped with APIs and tools that let it manipulate the digital world? If it can actively pull levers on the internet, is it embodied? It's a question that forces us to completely rethink the very definition of a living, thinking machine. Thank you so much for joining me for this explainer, and I really hope it changes the way you look at the future of AI.